by changing the intervals. Means we have already discussed. I have already reduced the Euler's formula in the range alpha to alpha plus 2 pi. If the period of a function is fx is 2 pi, then I have deducted or I have reduced the formula, that is fx, and I got a0, an and bn. So if there is change in the interval, that means if the period of the function, if the period of f of x is 2c, where c is a real number, then I can expand, or if the period of this or x lies between your alpha plus 2c to your alpha, then f of x, this is said to be one Fourier series. If f of x is equal to a0 by 2 plus the summation of an cos of n pi x by c plus bn sine of n pi x by this is c, as n varies from 1 to infinity. This is said to be one Fourier series if the value of your a0 is 1 by c into the integration of alpha to alpha plus 2c. This is your f of x into this is dx. And the value of your an is 1 by c into the integration of alpha to alpha plus 2c. This is your f of x cos of n by x by c into this is dx. And the value of your bn is 1 by c into the integration of alpha to alpha plus 2c f of x sine of your n by x by c into this is dx. Now, if the period of fx is 2c or else alpha lies in alpha to alpha plus 2c, then this fx is said to be one Fourier series. In a0 is this, an is this, bn is this. Okay? Now again, let us take your case number 1 for this. Now, if your alpha is equal to say 0, that means that is your x lies between, what is this, 2c to this is 0. Then the value of your a0 is your 1 by c into the integration of 0 to 2c f of x dx. And the value of an is 1 by c into the integration of 0 to 2c f of x cos of n by x by c into your dx. And the value of bn is 1 by c into the integral of your 0 to c
f of x.
This is your f of x
Sine
into the sine of
n
by
x by c dx.
This is dx. Okay. Now, case number 2.
Case
number 2. If alpha is equal to minus of c, or your x lies between your c to minus of
c,
then the value of your a0 is 1 by c into the integration of minus c to plus c f of x into dx. And the value of an is 1 by c into the integration of minus c to plus c f of x cos of n by x by c into dx. And the value of bn is 1 by c into minus c to plus c f of x sine of n by x by c into
dx.
If for specific interval the value of a0, an and bn are different, then let us take some case for your case number 2. Now if f of x is an even function, if f of x is an even function, then now you know that the value of your a naught is 0.
0.
Because minus in plus, no, not 0. This is not 0. The value of bn is 0. bn is automatically
0 because sine even into odd is equal to odd.
Minus to plus even function in the
And the function is order.
So this is the value of a naught is 2 by c into integral of 0 to c f of x into
dx.
and the value of a n is 2 by c 0 to this is c f of x cos of n pi x by c into
dx.
Then the required Fourier series is your f of x is your a naught by 2
Plus
plus the summation of
p and
n cos
cos
of n by x by c again varies from
1 to infinity.
This is called
Half.
the half range cosine series. This is called the half range cosine series. Okay? Now you take your another case. If
F of x is odd.
f of x
Is not function.
is an odd function, is an odd function.
Then n.
If f of x is an odd function,
Then
and
n naught
minus c plus c odd function into dx is
0. This one is
minus c plus c odd function into even function dx is 0.
then
So only thing that you have to compute your bn.
p n equal to 1 by
bn
c.
is 2 by c into the integral of 0 to c f of x
Sine n pi x
n pi x
by c into dx.
Then the required Fourier series is f of x is your a naught by 2 plus a naught, but I know a naught, there is no question of a
And
naught.
only b.
Plus a naught is 0,
A n is equal to
is 0 or bz. Okay?
so b n
So
only.
f of
Summation.
x is nothing but bn sine of n by x by c
Summation.
as n varies from 1 to infinity.
So it is a half
This is
sine.
called
Half range course
half range
sine series.
sine series. This is called the half range sine series. Okay?
हो सर ठीक
आपको
है
मैं आपको पूरे
ठीक है